Okay, so I'm going to record another session of chess because I wanted to take a break from grading work with my students. I think I want to do something quick. So last time we were looking at just the basic setup I had. I was looking at. Um, I'll show you this. Oh, I didn't set that up right. 1 second. I think this is the one. Yeah. Okay. So I was looking. This is the window I was looking in, and I'll just resize this a bit. Is that better or worse? Maybe it's better if I. Okay, just let me get set up. Okay, good. All right. So this is the Jupyter notebook I was working in, and yeah. So I built a basic engine that just computes a score for every position and decides which position is its preferred or has the highest score. And then it didn't work so great. So what ended up happening was, it would do things like the score was just based on the material count. So it was trying to count up how much material it has versus how much the material the opponent has, and whatever the difference is would be the score. And so as a result, it would do things like just take pieces without considering that the piece that it took with would be hanging afterwards, and then it just wasn't able to win. So in fact, this is the log of, I think this was playing from this winning position. It was playing against, yes, just a dummy engine. So dummy engine just plays a random move. Score engine is the supposedly smarter one, and it wasn't able to win. I think it ended up just losing all its pieces, and eventually it didn't draw. It hit some kind of maximum game length. It's still winning here, right? So there's a pawn here, but it just didn't know what to do, and was unable to make progress. So I don't want to go out of this paradigm yet. So in this setting, all we're doing is computing a score based on the current position. I don't want to. What I want to get to eventually is something that looks ahead. Right? This is how, at least even modern engines use this now, where they consider, okay, what will the opponent do if I do this move, and they sort of consider multiple moves ahead. It's kind of similar to the way we do it, but in a more computery way. I don't want to do that yet. That's the next phase. So because I just want to have a quick session today, I'm just going to try to improve score engine. So all it's going to do, it's still just going to look at the current the position after every possible move and decide whether to just score that position and decide whether to move forward. And in fact, generally that is the way almost all engines work, right? So you see, Stockfish and all those engines people use now, they have like a evaluation score for every position, and it's usually, based on the number of pawns they're up by. So it is also following the material count, but it's like adjusted by how things, other aspects of the position. So a couple of things I want to do is, first I'll just refactor so that I can generalize this, and then I'll work on improving that score. So here, this is the function. This is the function that I was using to make the decision. It's a function that receives a board, which is a Python chess object, contains all information we need to evaluate the position, and then it looks at all the possible moves. So first it gets a list of legal moves, then it looks at all the moves, and then it applies the move to a new board, which is like just a copy of a sort of a board that we're imagining, and then it counts the material. So what I want to do is I want to replace this with a generalized scoring function. So I think I can do that just by, I think what I'll do is I will cut this. I don't want to cut it because I might lose it. I want to be careful. So let me just write what I'm going to do first. So I'm just going to change change material count to score, and I'm going to say equals self dot. Sorry, I'm doing some stuff out of order. This is like hacking where you're keeping track of stuff in your brain. So I apologize for that. So we're gonna just do new board. So it's just gonna be some function that takes in a board and returns a score, and then we're just gonna say if the score is better than the best score, then we're gonna keep it. Otherwise, we're gonna move on. So now I'm gonna take this and put it all inside a score function. is let's put it up here. Let's say, let's call this material count, and it's just going to get a board. Let's call it new board just for, okay, it's not the best naming. I can adjust that later. And this is not great Python style. This should be, well, I should be commenting all these, but I'm trying to do this fast, so let's not do that now. So this is a function, and we're going to use a little bit of functional programming here. I'm just going to say that, and whenever you initialize the score engine, you have to give it a score function. So the score function, let's say, and by default, it will just be material count. Material count. I think that works. And then we actually have something to do here. So we're going to say, we're going to store that. Score function equals store function. There's a little bit of a stylistic thing here that's not ideal. The fact that this is kind of overloaded, but it's all right. It's not too hard to understand. You know, the computer just uses as symbols, but for us, I think it's okay to use the same name here. All right, so yeah, so I shouldn't have changed anything. Everything should work the way it did before. So let's see if that's true. So everything's running kind of slow. I think my streaming software is eating up my CPU. But anyway, so this is going to play against dummy engine, so I don't want to do that. I'm gonna get rid of this cell just because we don't need it anymore. Okay, so this one plays this dummy engine against dummy engine. Also, I'll just get rid of that just to clean things up. All right, so here now we're doing this again. That's fine. I'm all right with this. So this reloads it. I think what I want to do is just for cleanliness is just get rid of this. All right, so just to make this a little bit cleaner, so I'll just reset, clear everything out, just so we don't have any lingering things. All right, so we do this magic. This thing up here just makes it so that any external files we load, we import into the notebook will be re-imported every single time we run any code. That way we can edit those external files and see the changes. So now we import all the stuff we need, and we load the game that I wanted to play. And now we're going to do this game. So this is going to be score engine playing as white, dummy engine playing as black. Let's see what happens. It should be the same type of result. This one crashed. Okay, so yeah, now I have to debug what I did. What did I do wrong? Self's not defined. Oh yeah. So when I copied and pasted from inside a self, since I'm using these piece values. All right, we're going to do this a little bit. I have to think about what the right way is to do this. I'm trying to define a constant that we're going to use in the class. Really, it should be, for style-wise, it's a constant, so I'm going to make it all caps. And I think here, we just want to do piece. And then I'm starting to how to spell peace. P-I before E, right? It looks weird in all caps. Anyway, this looks okay. I think it should work now. Am I missing anything? Let's try it again. But board is not defined. I think I have to say whose turn it is. This is going to be tricky, so I have to remember to do this. So I'm just going to say equals turn, and then that's going to be part of the requirement for this score function. It has to always receive the turn that is currently being considered. So that would be board.turn, and we'll try one more time. Come on, hopefully it works this time. That's not what I wanted to run. I ran the wrong cell. Okay. I want to run this cell. Crashed. None type in int. Oh, I didn't return the value. these little things happen when I so one of the things I mentioned last stream, I'm implementing this in Jupyter Notebook, which that's not normally where I would be programming in Python, because it doesn't have as many of the features as you want for like debugging and other IDE features. What do we want? I want to return material count. Although I don't even know if an IDE would have told me this. I just forgot to return something, and technically this is still a valid function. So anyway, now it's what should be closer to what I want. So hopefully this works. Again, I don't want to run that cell. I want to run this one. Nope, still something not right. Int and function. Aha. Material count is overloaded. So it is confused because I named it two different. I named two different things material count. So let's call this. I don't like calling it count. What's a good name for this? All right, let's just say material difference. And yeah, renaming variables is a lot faster in an IDE. Maybe there's a command to do it in Jupyter that I don't know of, or a plugin or something, but it always just feels a little slower. Okay, almost there. I missed one more. This should be score, right? I think that should work now. Okay, all right. Now this is doing what it did before. This is the next cell. I'm going to delete this one also. I might regret that because it's useful to have. But all right, so this is all we're doing. All we do is load this game and then have it play against the dummy engine. What the heck? Oh, I think I'm starting with a new board. I think I wanted to go like this. All right, so this is starting from that winning position I had, and it plays and it does some stuff. Let's see if it. I doubt it will win, because so one of the things I know that it won't do is it doesn't know about checkmate. The score engine doesn't even know how to win at chess. So for one thing, we want to add the ability to do checkmate, or to know that checkmate is worth more than anything else. So what I would like to do is create a new score. So let's call this improved score, and it receives new board and turn, and I'll start by saying score is equal to material count. All right, so first it gets the material count, but now we want to augment it, and in the end we want to return score. So in here, add extra score strategies. So how else do we want to augment it? So I was thinking a couple of things, like, yeah, for sure we want to look for checkmate. So there's a way to do that in Python chess. I think is checkmate. Okay, checks if the current position is a checkmate. So let's say if new board is checkmate score, we're just going to add like a huge number to this, and this would be on the next turn, so it has to be the player that's making the move right now making the checkmate, so, or delivering checkmate, so it should be a positive score. So I'll just add, a big number. At some point I want to replace these with constants. I'll just use that for now. I think I had a note like that earlier too. Yeah, make this not ugly. All right, it's fine for now, since I want to get this done quick. I'm trying to finish this by, it's 3:37 right now. I want to finish it by 4 p.m. So in addition to checking for checkmate, I also wanted to, I have to think about something like space maybe. So one thing we can just count is like how many squares are under attack, and we can do that. There's a function in here I was poking around earlier. attack. So there's the attacks. So this is the set of attack squares from a given square. And then note this is not fancy enough to, or like this function is by design checking if it doesn't consider the fact that pieces might be pinned, so they might not be allowed to move. But so just assume that a piece is free to move, and then it sees what squares it can attack. That's not exactly what I want. I think maybe an easier way to do this is just to count out here. Is attacked by. So check if the given side attacks the given square. I think this is what I want. So if I go through every square and I just count how many squares are under attack by the opposing color, then we can get a rough count of the space advantage. Yeah, I'm not sure if that's going to be, super great, but let's try it out. So now one question is, what do we have to pass in here? So we have to pass in the color and the square. And is there a way for us to get all the squares? I don't want to have to just like type in, how do you get a square? Let's see. Square A1, B1. Okay, looks like you can get all of them, but can I just get all chess.capital squares? Okay, I think I have an idea of how to do it. So let's do compute space controlled by color so let's say 0, and we'll just do for square in chess.squares, and then we do, I think we do if I actually want to check if controlled. Well, that's fine. This is fine. So we're gonna do new board is attacked by, and then color would be, let's say turn. That's the current turn. So that's the current player. And then square, I think. Then space. We add 1 to the space, and maybe I should. How do I get the opponent of a specific player? Okay. I mean, I know the, like, what I don't want to do. So what I know is that Python chess stores the current turn as just a true or false statement, and so I could do like not turn, which would invert it and give the other player. But that's like going under the hood. It's not good programming practice. Another possible way to do this is to get the turn of the new board. Right, so turn here was, this also is not great because it might not be. All right, I'm just gonna, okay, I'll do it again. I'll do it fast, and it's not my favorite way to do it, but let's subtract away squares that the opponent controls. So the way we would do that is not turn. Okay, so what we're seeing now is this should now be the space advantage. So I'm gonna, and I don't feel like that should be worth as much as a pawn. We have to guess what these are. Like a real smart algorithm, smart AI engine would have like a learnable weight on how to trade off between these ideas. But I'm just gonna guess. So let's say score is going to be, we're going to say that I'll just do 1/32. I don't know, something like that. So let's see the behavior now. If we use this, and I think we'll have to just change score engine to use to import it. What did I call it? Improved score. So now I'm asking the score engine to use the improved score function instead of just the material count. And let's see if it makes any different moves. Or I mean, it should make different moves because it crashed. Wait, did it crash? What happened? Oh, it didn't crash. It's using the board from the end of the last game. Okay, so this time, okay, it still doesn't seem like it wins because I think it would have won a lot faster if it was. Did it win? No, it just runs out of time. There must be some maximum game length in Python chess. So let's see, the first move, so it probably still prefers that material gain here. So this is dummy engine making a move to a defensive move to get out of check, and then score engine takes that piece, which is good. Does this actually help? How do we know? What's a good check to see if it's... I mean, in the end game, space is not really going to change much, so that actually might be why we're not going to see different behavior. So maybe I'll do this with a new board and see what happens. So just for a quick check, I'll just do board equals chess.board. I think that's how I begin a new game. Okay, so now from a new game, so again, score engine is playing as white, e3. Okay, I guess technically, yeah, I suppose e3 is no better than e4 according to just space, but okay, that's fine, I guess. Then it moves the queen out, and then it's gonna, okay, then it then it takes the pawn. All right, so this doesn't address this problem that we saw last time. So here the score engine saw that it can reduce the material imbalance, or it can increase its material advantage by taking this pawn, right? Not realizing that the pawn is defended. So this might not be possible. I mean, I don't want to hard code too much look ahead into this, because really that's what the look ahead algorithms are meant to do. Like, it's supposed to say, okay, well, what happens if I take this piece? What will the opponent do if the opponent plays smartly? And clearly, if the opponent was also being controlled by score engine, it would have a huge advantage as it is able to take the queen for free after the next move. So I don't know if there's a different way to sort of statically score that. It's an interesting question. I'm not sure. Oh well, so yeah, I mean, yeah, this is obviously, dummy engine did not take back, and then score engine was able to get the free rook in this case. I'm guessing after that it'll get the free. Okay, then it takes the free knight, and so it's doing okay. But it's obviously it made an error that a smarter opponent would have taken advantage of. At some point, as I flipped through this, it lost the queen. I didn't see where that happened, but that's typical of this engine. Dummy engine loses its queen as well. Yeah. So yeah, then they just shuffle their pieces kind of randomly because there's nothing. I mean, okay, well, score engine's doing pretty well in terms of, like, it's probably going to be to win this position, but I shouldn't say it that way. Any intelligent engine should be able to win this, but score engine may not be able to do it yet. Although oh, interesting. Is that just random luck that it actually promoted the queen or the pawn? Because here there's no advantage, there's no space advantage gained by moving. Oh, unless I wonder if this does create a space advantage, because the rook is now attacking a new square that was not under attack before. Because unless they count it as under attack, I'm not sure how the Python chess calculates that is attacked by function. But the one possibility is that, like, A7 is not under attack, that's right, yeah, it's not under attack because it's blocked by the pawn. So maybe they calculate it that way, and then when you push the pawn, you actually get, well, a7 is still not under attack, but a6 is then under attack. So maybe that's what it's doing, and that's why it was incentivized to push the pawn, and then of course here it's incentivized. Sorry, here in the next move, it's incentivized to push the pawn to promote, because in that case it has, you know, a bigger material advantage. So does this actually, was it checkmate? Oh yeah, it actually checkmated. Probably not the most efficient way to do it, but yeah, it formed a mating net. So here's the bishops cutting off the diagonals, and the queen's got everything here. Okay. All right, it's improved. I technically accomplished my goal is to be able to win from this winning position. It probably didn't do this the most efficient way, as it, you know, oh, sorry, this is not even a winning position. This is from a starting position. Oh, right. So back to the original position. I suspect it still won't win. So let me try it again. I mean, sometimes it will. There's randomness involved as well, so it might win sometimes, but it's not. You know, a good engine should be able to consistently win in a position as dominating as this one. So right. So now, right. It's. Let's see how this ends. I suspect it's, yeah, it doesn't. That's not a checkmate. So it again ends because of some maximum game length condition. So as a result, yeah, so I'm not fully satisfied with what we did. So all we did was add space. So what else can we add? I mean, I do really want to get rid of that hanging piece issue. So maybe one thing I could do is I could just remove the material value of pieces that are fully hanging. But is there a way for me to calculate that from Python chess without, you know, I don't want to resort to like calculating every single grid entry and figuring out, oh, is it diagonal from a bishop like that? That'll be really expensive. Not for a computer, but for me, it'll be expensive for me. So instead, ideally, it's been pre-implemented in Python chess, which is likely, but not necessarily true. So there's like, they have the checkers function, which sounds funny. It sounds like it's about the game checkers, but no, it's about the pieces that are currently checking the king. So what I want is something like that, but for just a square, not the king. So like all the attackers, I guess, is what I want. So did I have that? Did I see that? Attackers. Yeah, this works. So how do I do this? I guess we can look at, for every piece, I can calculate the number of attackers and defenders, because this can let me get defenders. And you know, this isn't completely correct because it depends on the value of the pieces that are attacking and defending, but let's assume they're all like pawns, right? So if that's the case, well, that's obviously not true, but let's say they're equal value, in which case we just have to count the number of attackers, which is what we do. A lot of humans do that anyway when they need to quickly calculate. You don't actually, you know, it's not really correct to just look at the count because it depends on what pieces they are, but a simple version of doing it is just saying, you know, 3 attackers, 3 defenders, this piece is not hanging. So let's try that. So I'm going to try to, okay, a few more minutes. Let me try to look at, for every piece. By the way, I have this all pieces thing, which is not the best way to do it. In fact, I think there's just a thing called pieces, but I'll fix that. I don't want to fix that now since I'm low on time. That technically works. At some point I'll make the code prettier, but for now I will just use what works. And similarly, I will borrow this code. So remove hanging pieces from material. Just got a message, but I don't know what device. Too many devices. Okay, so for piece in pieces, all pieces. All right, so now we're going to say attacker, let's call, attack count. I think for now I'm just going to remove the value of hanging pieces that are owned by the current player. Like that'll avoid this problem of just hanging your queen to get a pawn. I don't know. I feel like there's if you remove the value of a hanging piece by the opponent, it's not the opponent's turn, or rather, it's not your turn at this point. So if a piece is hanging, it doesn't really matter right away. It might matter later. But all right, so let's detect the hanging pieces. So attack count is going to be equal to, I guess first thing is if piece dot, I'm going to say color maybe. Pieces color equals turn, and then attacker count was going to be, I think we can probably just do the length of the list that's returned by attackers. It's a set of squares, a set of attackers for the of the given color for the given square. Okay, so we give color and we give square. So we want to look at the opponent's color, and we want to look at the current square, which is probably piece.square, but let's see. Pieces. Do I not get square here? Okay. That is annoying. So I think what I need to do is I have to figure out the square that this is on by changing the value of all pieces. So it's the list. So, okay, this is coming out of a map. So those of you who know Python, this means that this is going to have a key and an item. The key is the square, and the item is the piece. So I think we want square and piece in all pieces. I think that should work. And now I'll do piece square. No, it's not, just do square. Oh no, I did this wrong. I meant to say new board dot. Oh wait, is this piece dot attackers? That's interesting. So it's in the piece object. No, that's in baseboard. It's in the board. So board, I give the board, I give the square, I give the color. So it's new board dot attackers. Then this is the color. Then this is the square. That should be the number of the attack count. Defender. Let's say attacker count. Defender count is equal to. I'll just repeat that, and this time it's turn. Okay. And now I'll just say if attacker count is greater than defender count, then we're just going to subtract. So score minus equals. Oh, this is so ugly. All right, so I'm going to have to do piece value in this thing. I'll do this thing. Piece values, piece.symbol.upper. Okay. Will be cleaned up someday. Yeah, that should do it. Let's see if it still hangs the queen on that situation. I mean, first off, it's probably going to crash because there's probably a bug, but yeah, that's the end of the game, so that didn't tell us anything. All right, so I'm going to run out of time, but it looks like we're not, we made progress. This did not win from the winning position. I think end games are going to be tricky without look ahead. I think it's pretty hard to do end games, but let us try a new game and trace through and see if it makes sense. Actually, I do have a few minutes, so let me do board equals new board. Nope, that's not how you do it. Chess.board, and then I will just play a game against. Let's play a game against Score Engine. So console player. Let's try it. So, okay, so console player played E3 again. I have no idea how to play against this because this is not a normal. I mean, it is an actual opening. I'm sure. I don't know it. Okay, well, I'll just take the center, I guess. So E7, E5. All right, queen's out. Let's see if they, just hang the queen. So let's attack the queen right away. See if that does anything. G8, F6. Okay. Well. Okay. Why did it do that? So Score Engine, seems to not like that the queen, was hanging here. Oh, I think I know why. Because the queen is defended by the pawn, right? So it didn't, according to my score function, it doesn't lose the value of the queen here. So that's a flaw in the function. So right away in the third move, we identified a problem with what I did, but we got a little bit closer. This is interesting. I think we do have to consider the piece values when we calculate whether a piece is hanging. Yeah, we can't just count the defenders and attackers because it's just not the right thing to do. Yeah, this is. Yep. That's not correct. All right, let me cancel this and just see what, and then probably it will lose really bad, but let's just play it against, well, no, they might not lose. If I do it against dummy engine, or better yet, score engine, let's just do score engine with the material count. Okay, so we're playing a game where white is going to be the score engine with considering space and trying to avoid hanging pieces, but not perfectly. And the score engine is just going to the black pieces will be controlled by just material count. So again, it really loves E3. The black player gains a little bit more space, I guess. Does it really gain more space by doing that? I don't know why I chose that. Okay, there's a queen attack happening. Let's see, anything interesting? A random rook move. Don't know why. Is there a reason that none of the moves increase the space advantage? I mean, shouldn't it? Shouldn't pushing a pawn increase the space advantage by the way that I was calculating it? Maybe there's a bug. Okay, random queen move. This is gonna be terrible. I think it's just a bunch of random. Oh, yes, this score engine moving this rook back and forth. So yeah, this is not working yet. A castling? Surprising. Okay, wait, here's something interesting. So here, oh, I forgot which move was which player was which. I get so confused. Okay, so white is playing to improve space. Right, so black is the dumber engine that's only caring about material count, and that's why none of the moves are good, or none of the moves are better than any other move according to its score. So that's why it's just shuffling its rook back and forth. But here, well, this is a move that both engines would play. Just take the free pawn, but doesn't know that now this bishop is hanging and needs to defend it, or it's escaped. Yeah, it escaped. That's good. So bishop, it escaped, not to the best square. It's okay. It's not terrible, but and then the dumb score engine just takes the piece, not realizing that it's a trade, although that's actually a good trade in this case. Anyway, so okay, free rook. I'm sorry, not free. The rook claimed the free pawn, supposedly free. But now, does the white player know to take back? Yeah, it should, right? That's a material difference. So far, some of this is pretty easy to understand. Let's see what happens if we fast forward, because I have to get going. So fast forwarding, white has developed, but seems to be something doesn't look right here. So okay. What's the material count? So white has 2 rooks, black has only 1 rook. three minor pieces, and pawns are the same. So it looks like, yeah, white's winning, so that's good, I guess. And again, the score engine with just material count is confused here. It doesn't know what to do, so it's shuffling. But does the space actually help? And no, it seems like both players are just shuffling their pieces really randomly, not making any progress. White moved the king out, perhaps to gain some space. That's a little strange. I'm not sure why that would help. I guess this square is now under attack by the king, so maybe that's why it did it. Now it's just moving back and forth. Everyone's just shuffling their pieces. No one's making any progress. Maybe it's just going to end here. I think it's just going to end here. Okay, so there's still more room to improve. So if I have time, I think I might want to invest in doing the look ahead algorithm, so the minimax algorithm soon. But I might want to spend more time just trying to refine the score function, because ultimately, even if you have a look ahead algorithm, you still have to have a good score function. And I would like to have. I mean, let's think about this. So what is the when white made this move, what move should it have made, and what information would it use to do that? And we have to try to think, like, is it using, if we as humans can think of a move, if it's based on thinking about what we do, then what the opponent will do, that's look ahead. But if instead we can just say something materialistic or something about the current position, like how many squares are under control, then we might be able to just add that to the score function. And there's definitely room to improve that hanging piece logic that I had. Maybe something about like attacking pieces. Yeah, we need to learn to threaten pieces. That's something that we're not doing right now. So, okay, so that could be a plan for next time. Anyway, I'm gonna get going. Hope you enjoy the video, and the couple people watching live, hope you got something out of it. Anyway, all right. Have a good afternoon.